So central tendency, mean, median, and mode. Remember, that's what showed us what the typical case was. What is average? Variation will tell us how scores are spread around that central point. That's what variability is. It's the distribution, or it's the spread of scores around a center point. Variation only happens with numbers, so we are only dealing with interval and ratio level data. So you get to forget about nominal and ordinal for 2 days. That's good. We're just dealing with interval. We are going to work with means though. Mathematical averages, we're going to add a couple of steps to that to find variation. First variation method is easy. Range. Range is your high score minus your low score. That's it. It's that easy. That's all there is to range. Range is really rudimentary though. Range doesn't tell us a lot. It's a crude measure. All it does is tell us the difference between our highest number and our lowest number. So let me show you what range looks like. All right. So if these are the ages of students in our class, 18, 18, 19, 19, 20, 20, 22, and 23. Let's figure out the range. Highest, age of 23, minus our lowest score, age of 18. What's our range? 5. Yeah. 23 minus 18. That's all there is in range. Range doesn't tell us how many students are at the high end. It doesn't tell us how many students are at the low end. All it tells us is there's 5 numbers between our most oldest student and our most youngest student. That's it. That's all it tells us. Okay, let's take a look at another example. 18, 18, 19, 19, 20, 21, 22, 43. What's our highest? 43 minus our lowest. 18, which is, if you don't have calculators out now, good Lord, you need them. Pull your calculators out. 25. So this range is telling us there is 25 numbers between our youngest student and our oldest student. Again, it doesn't tell us how many are on the young side. It doesn't tell us how many are on the older side. It doesn't tell us if we have a class full of non-traditional students. It doesn't tell us anything other than there's 25 spaces between the highest and the lowest. That's all. Not super useful. I know this is a nice, friendly, easy one. You're not going to be tested on this. This is easy. Yeah, sorry. But that's what range is. If you ever see a study that tells you the range, you should put it down because that's a crappy study. They did a bad job. You don't care about range. But it is a rudimentary measure of variation. Let's move on to the harder ones. Starts with the idea of deviation. Deviation will tell us about every single score. Remember with the range that was really happy and easy just now? All it told us about was the highest score and the lowest score. It didn't tell us about every single score. We need to know about every single score. So we're going to move forth into variance and standard deviation. Deviation, the definition of deviation. Distance of any given raw score from the mean. So we're working with some letters here, nothing new. X, remember, is our raw scores. X bar is our mathematical average or our mean. So to find a deviation, raw score minus the mean. That's your deviation. We're going to build on deviation, but here's the basic building block. Here's your Lego base. Score minus mean. Okay, so let's start with an easy data set. We've got 18, 20, and 22. That's our data set. What's our N? How many people are in that sample? 3. Yeah, the person who's 18, person who's 20, person who's 22. There were 3 people that we asked. So we know our n is 3. Let's figure out the mean. 18 plus 20 plus 22. What does that give us? 60 divided by our n, which is 3. What's our mean? 20. Okay. So what's the deviation of 18? 18 is the x that I'm asking you about. So we're going to do the x minus the mean. 18 minus 20. What do we got? Negative 2. Negative 2 is the deviation of 18. Not bad, right? We got this? We okay to move on? Yes?
Okay. The raw score, how did we find out the deviation?
How did we find out what the deviation is of the raw score?
Yeah, the 18 minus 20. How did we get that 18?
The 18, it's the random number that I pulled out of my ask from this data set to ask you about.
It's still the highest minus the lowest, right?
Highest minus lowest is range. Deviation is whatever raw score I ask you about minus the mean for that data set. So what's the deviation of 20 in this data set? 20 is the raw score I asked you about. 20 is the raw score I asked you about minus the mean, which is 20. So what's the deviation? 0. What's the deviation of 22? 22 is now the raw score that I'm asking you about. Raw score minus mean. So raw score is 22 minus the mean for this data set, which is 20. So what's the deviation of 22? 2. The deviation is whatever raw score I ask you about minus the mean for that data set. You got it? Okay. All right, now here's the problem with just using deviations. We already did this just now because you're so good. We did the deviation of 18 on the top line. Raw score minus mean gave us a negative 2. We did the deviation of 20 on that middle line. Raw score minus the mean gave us a deviation of 0. We did the deviation of 22 on this bottom line. 22 minus 20 gave us a positive 2. What happens when we add up all of the deviations? What do you get? 0. Negative 2 plus 0 plus positive 2 is a 0. Deviations in and of themselves, if we do a deviation for an entire data set, this is only 3 numbers, but if we had 100, it would look the same way. The problem is, when we add up all of the deviations, we end up with a 0. So there's no math we can do with just the deviations. We're going to take it a step further. In order to not get that 0, we're going to square our deviations. We can't do math with a 0. 0 times something is 0. 0 divided by anything or anything divided by 0 is 0. Not a lot of math we can do with 0. So we square those deviations. The squared deviations are going to give us variance. Definition of variance, bottom line here in red. Variance is the mean of squared deviations. So variance is the mathematical average of those squared deviations. That's what variance is. We got that? Variance, by definition, it's the mean or mathematical average of the squared deviations. All right, here's the formula. Now stop. Stop, stop. Yeah, stop. This is the technical formula. I'm going to walk you through this, and then I'm going to teach you an easier one. Okay? So this is theoretically where it comes from. Do not write this down. I don't want you to do it this way. This is longer. I'm going to teach you the short way. But first we're going to go through the long way so the numbers make sense. Formula for variance. We know what that funny looking E is. That means sum. We know that, right? We learned that with mean? Yeah, we got it. Sum. S-U-M, not S-O-M-E. Sum, adding things up. X minus X bar, or mean squared. So what the top line of that formula is, for every data point we have, for every X we have, we subtract the mean, and then we square the result. Not bad when we have 3 or 4 numbers. Horrible when you have 1,000 or even 20. Yeah, that's why we're not going to do this one. So we take every single data point, subtract the mean, square the result, and then we divide by n, the number of people in our sample, the total number of people that we asked. Variance, you know, because we do nicknames like X bar is mean, MO was mode, MDN was median. S squared is your variance. If you see S squared, it means variance. Always. It doesn't mean square anything else. Treat it like the word Bob. S squared is your variance. We could have made it easy and picked the word variance, but we wanted to make it harder, so we used a random letter and a number. S squared is variance. Okay, S. S is standard deviation. Once we get S squared, we take the square root of our answer, and that gives us standard deviation. Standard deviation is the one we're going to be working with the most. Same formula that we just worked through, except now we're taking the square root of it. So you would still take every single raw score, subtract the mean, square the result, add all of those up, divide by n, and then take the square root of that answer. And that would give us standard deviation. Remember that variance was the mean of our squared deviations? Do you remember that? 2 or 3 slides ago? Because we squared everything, we've got to back up and square root it at the end. Variance was our squared deviation mean. Standard deviation is the average mean. It's the average variance. It's the average that every score is away from that mean, that center point. So the variance is the average of all the squared scores. Standard deviation is the average of all the scores. So I know it seems complicated. Basically what we did was we squared everything to get positive numbers, added them all up, divided by n, and now we take the square root to get rid of the fact that we squared everything in the first place, to not have 0. All right. S squared is variance. S is standard deviation. Just a repeat of what I just told you. S squared, or variance, average of squared deviations. The S is what we're really interested in. The S is the average. Each score deviates from the mean. So the variance doesn't tell us a lot. The average of the squared deviations, we need to know the average of the deviations. We don't need the squared deviations. So we find S. Find your variance first. At the end, find the square root. Nothing crazy. It's a button on your calculator. If you're using your phone and you can't find it, turn your phone sideways. It's on there. Yeah. All right. Here's an example. Again, just eyes up. Pay attention. You don't have to write this down. We're not using this one. All right. So, again, because we like happy examples in this class, here's the data set of weeks of unemployment. Our data set is 9, 8, 6, 4, 2, and 1. First thing that we need to do, we need to figure out the mean, because we're going to have to take each data point and subtract the mean. We've got to figure out the mean. So we add all of those up. 30, and we divide by n. What's our n for this data set? How many people did we ask about their weeks of unemployment? 6. So we add everything up to 30, divide by our n, which is 6. 30 by 6 gives us a mean of 5. Okay. Next step, for each data point, we subtract the mean. So we have in this bottom table down here, 9 minus the mean of 5 would give us positive 4. 8 minus the mean of 5 gives us positive 3. 6 minus the mean of 5 gives us positive 1. 4 minus the mean of 5 is negative 1. 2 minus the mean of 5 is negative 3. 1 minus the mean of 5 is negative 4. We know if we added those up, it would give us 0. So we have to go to the next step. Square everything. Positive 4 squared is 16. Positive 3 squared is 9. 1 squared is 1. Negative 1 squared is 1. Negative 3 squared is 9. Negative 4 squared is 16. We've gotten rid of all of those negatives. So now when we add everything up, it's not 0 anymore. We add everything up and we have 52. We're going to take 52 and we're going to divide by n. We already know what n is. We used to define the mean. It's 6. So we're going to have 52 divided by 6. Our variance, our s squared, is 8.67. So from that mean of 5, all of our squared deviations are an average of 8.67 spots away from that mean of 5. Doesn't make a lot of sense because we're still dealing with squared. So let's take the square root of it. So 8.67, we take the square root of it. We have 2.94. So what 2.94 tells us is the mean in this data set is 5, but the distribution, the spread, the variance, or the variation, every score in this data set is an average of 2.94 weeks away from that mean of 5. That's what the 2.4 comes down to.
Are you willing to say it again as if you were explaining the chart? So say, Amber, what this is telling you is that so-and-so had this many weeks and that's 2.94 weeks. Because I think I'm having a hard time applying why these numbers matter to me, what they're telling me.
Okay, well,
Besides the math of it.
sure, it does, and it's going to make a whole lot more sense when we get into the next chapter and we move what standard deviation is, but let me show you kind of a quick summary, okay? All right, so here is our data. We had 9, 8, 6, 4, 2, and 1. The mean, the center point, was 5. In our data set of 6 people, the average person was at 5. That was our mathematical average. Now this 2.94, what that tells us is how close each of the data points are around that center spot, or how far each of the data points are from that spot. Gets a little tricky though, because 2.94 is that large or small? Well, it depends. Are we dealing with numbers 1 through 5? Because if we're dealing with numbers 1 through 5, if we're dealing with numbers 1 through 1,000, if we're dealing with numbers 1 through 1,000, 2.94, that's tiny. We've got 1 through 1,000. They're only 2.94 spots away. If we're dealing with numbers 1 through 5, that's huge. There's only 5 numbers, but they're all 2.94 away from the center. So in and of itself, it doesn't tell us a lot without the information from the data set, but we're going to build on that when we talk about probability, sampling, some of the other concepts. So great question, and we're getting there. I just don't want you to get there yet. I want to get us used to finding standard deviation, and then we'll get into probability. Okay, so how do we feel? Ready to see the easy one? Okay, that's a little bit of a lie. None of them are easy. This is easier. This is the shorter. This is the faster. I promise you this is faster. I promise you. This is called the raw score formula. Raw score formula. Funny looking E. We know what that means. It means add up. X squared we're going to take each of our data points and square them and add them up. We're going to divide that by n, and then we're going to subtract the squared mean. So we still find the mean, we're just squaring it this time. I know that's a lot of words. I promise you this is faster. Don't be intimidated. No subtraction and then squaring and then adding. We're going to straight up square things and add them up, divide by n, and subtract that squared mean. With the raw scores formula, the formula doesn't change. Remember variance, s squared. Standard deviation is s. We find the variance and we take the square root of it. So s squared, that's our variance. S is standard deviation. Find the variance first. Take the square root of it, and that gives you s. Need another second to write this down? Are we good? I also got handouts for you. One more second? Sure. Okay. Now that I've scared you, let me show you how easy this is. All right. Same data set. Weeks of unemployment, 9, 8, 6, 4, 2, and 1. First step in this one is to square every single one of those data points and add it up. So 9 becomes 81, 8 is 64, 6 squared is 36, 4 squared is 16, 2 squared is 4, 1 squared is 1. Add that up, 202. We've now found the sum of our x's squared. You all see this slide? Okay, there's a theme in this class. The theme starts today, it's label your shit, or if you don't cuss, label your stuff. Care which one you use. Labels are important. You will get lost if you don't label things. So make sure you label it. This is the sum, sigma, that weird e, of our x's squared. That's what we just found, the sum of our x's squared. We squared everything and we added it up. Cool. Step 2, let's find that mean, and then we're going to square it. You know how to find mean. Everything added up, divided by n. So we added up all of our x's, all of our raw data points. So the 9 plus the 8 plus 6 plus 4 plus 2 plus 1, we've got 30. Divided by our n of 6 gives us 5. Now the x bar squared means mean squared. So take that 5 and square it, which is 25. 5 squared is 25. Congratulations, you now have every number you need. Top part of this formula, sum of x's squared. We labeled our shit. 202 divided by n. So we do the sum of our x's squared first, divided by n. 202 divided by 6 gives us 33.67. First part of the formula is done. Now we subtract the mean squared. We found the mean of 5. We squared it for 25. So we've got 202 divided by 6, 33.67, minus 25, 8.67. That's our variance. 5 that we squared. Is that the one you're talking about? Yeah. That's our mean. Added everything up, divided by n. We found 5. That's our mean, our x bar. We squared in this formula. So 5 squared gave us the 25. 8.67 is exactly what we found a couple of slides ago on the long formula. We just found it shorter. That's our s squared, our variance. Find our standard deviation, take the square root of that. We get 2.94. So same exact results. Just the faster formula. Yes? Square root gives us our s. What we find with the 8.67, that's our s squared. That's our variance. So if all we have to find is variance, we're done here. If we need to find our standard deviation, our s, then we've got to take the square root of that s squared. Sounds like a lot of words. We're not done practicing. We'll keep going. Okay, raw scores formula. we're going to practice. We're going to practice together. We're going to practice alone. We're going to come back and practice together again. Standard deviation. The important thing that we use it for, the reason we have to do it. Remember, with variance, we squared everything. So we changed all of our numbers. We take the square root, we divert back to standard deviation to get rid of the fact that we squared it. That's what standard deviation is. It is the average deviations from the mean. So from that mean that we find in any formula that we use, standard deviations is the average number that each score was away from that center, from that typical case, from that mathematical mean. Gives us something standardized. We are almost finished with the lecture, and then we're going to practice till your fingers are mad at me. In summary, range. Range feels like it was 100 years ago and not like 20 minutes. Yeah, range. Rudimentary. Easy, pretty worthless. Not super helpful. Doesn't really tell us anything. We get into variance and standard deviation, though. They reflect every score. They give us an idea about where every score is, and not just the highest score and the lowest score. So range we're never going to use. We're going to be happy it was in our life for a fleeting 5 seconds. It was like a dot of sunshine before the rain came in. Standard deviation and variance is what we're going to use. You have to have data at the interval or ratio level. So we get a couple of days off from ordinal, we get a couple of days off from nominal, but that means we're going to do more math. All right. Are we ready to practice? We're going to practice together. We got this.